What about our second kite right here? Well, we need to start off by remembering that the diagonals of a kite are perpendicular, which means that this is a 90-degree angle, and so C will also be a 90-degree angle. And in fact, we can just keep going if you wanted to. Those are all 90-degree angles. The diagonals of a kite are perpendicular. So what about D? Well, recognize that this triangle right here, we now know two angles out of three of them. We know this is 80 degrees and 90 degrees, so we can subtract from 180 and get that D is 10 degrees. Now, we know that in a kite, this top larger triangle right here is congruent to this kind of bottom larger triangle right here. And so this is 80 degrees. E will also be 80 degrees. Right? What about F? Well, to do F, we might have to do a little bit of extra work. We know this angle right here is 35 degrees, and this angle is 90 degrees. So we can do what we did before and recognize that we can get the third angle by subtracting from 180 degrees. So 90, 35, and then the last one will be a 55-degree angle. Just like before, this is 55, F will also be 55. Another way you could go about it is recognize that the diagonals bisect this angle and this angle. So this will also be 35 degrees. This will also be 10 degrees. And you can use any of those methods to find what F and D are. Again, C is where you start, knowing that the diagonals of a kite are perpendicular. What about for this third one? Well, it's pretty clear to see that G will be 5 because this diagonal is bisected by the other diagonal. What about H? Well, remember that the diagonals of a kite are perpendicular, which means that here we've created a right triangle. And how can we find the third side of a right triangle? We can use Pythagorean Theorem. So set up, that's 5 squared plus 12 squared equals H squared. 5 squared is 25. 12 squared is 144. Bring down the H squared. Add them together, we get 169 equals H squared. And taking the square root to get H by itself without the squared, we get 13 equals H. And so H must be 13 centimeters, which is pretty reasonable. It's longer than the other two sides, but not by very much. 17 and 18 require a little more thinking, a little more challenging, but not too bad. 17. The perimeter of the kite is 116. Find x. Well, we know that the total perimeter is going to be 116. What can we fill in here? Well, we know that this side is 28, and since this is a kite, this side will also be 28. Again, since this is a kite and this side is x, this side will also be x. We can take the total perimeter of 116 and subtract off the 28 from this side and the 28 from this side. Doing that, 116 minus 28 gives us just 60, not degrees, I'm sorry, just 60 to split between these two sides. Could be centimeters, meters, we're not sure. But 60 split into these two sides, dividing that by 2 gives us just 30 for each of these sides. So x will be 30. For 18, find x, y, and z. Now we're back to dealing with angles, and what looks like we have a kite and an isosceles trapezoid here. How can we do this? Well, in a kite we know that this angle and this angle will be congruent. So this angle right here will be 137. What about x? Well, we've got 3 of the 4 angles of a quadrilateral, so we know that the angles must add 360 degrees in any quadrilateral. So we can take 360, subtract off 22, subtract off 137, and the other 137, and we're left with 64 degrees. So x will be 64 degrees. This symbol right here, this angle with the line through it, tells me that this is congruent to the first angle. So this is 137 degrees. Right? Those are markings just telling you those are 2 congruent angles. So now we're into the isosceles trapezoid here. And what do you know about an isosceles trapezoid? Well, since these two sides are parallel, and this acts as a transversal, these are what we would call same side interior angles, and they're supplementary, which means we can take 137, subtract it from 180, and find that y will be 43 degrees. For z, since this is an isosceles trapezoid, we know that the base angles will be congruent. So whatever z is, it'll be congruent to this angle here, and so z will be 43 degrees. Again, only because this is an isosceles trapezoid, notated by these markings, these congruence markings on the sides. Let's take a look at 19. Answer the following questions with always, sometimes, or never. I will write A for always, S for sometimes, or N for never. As we go through this, I want to be thinking about these 2 questions for every single one of these always, sometimes, or never problems. Could A be B? What I mean by that is, could the first part have the second part? Is that possible? And the second question is, does A have to be B? Does the first part of these have to have the second part? So that might be a little confusing now, so let's do a few examples and get the hang of this. A rectangle is also a square. So could a rectangle be a square? Let's think. A rectangle has those 4 right angles. Could it be a square? Well, a rectangle could be a square if you suddenly gave a rectangle all congruent sides as well. That's fine. It's still a rectangle. So it could be, but does it have to be? No, a rectangle doesn't have to be a square because it doesn't have to have the congruent sides. It could just be, have, 2 longer sides and 2 shorter sides. This will be a sometimes because it could be a square, but it doesn't have to be. Another way of looking at this question is by thinking about the tree diagram. Remember, a square is a type of rectangle. So a rectangle could be a square sometimes, but it doesn't have to be. On the other hand, a square is always a kind of rectangle. B, a parallelogram is also an isosceles trapezoid. Well, think, a parallelogram is going to have 2 pairs of parallel sides, whereas an isosceles trapezoid has 1 pair of parallel sides. So could a parallelogram ever be an isosceles trapezoid? No, it couldn't, because it wouldn't have the right number of parallel sides. This will be a never. Again, you could use the tree diagram to help you out if you'd like. C, a parallelogram is also a rectangle. So a parallelogram, it's got those 2 pairs of parallel sides. Does a rectangle also have 2 pairs of parallel sides? Well, yeah, it does. So a parallelogram could be a rectangle, but does it have to be? No, it doesn't have to be a rectangle because a rectangle also has these 4 90-degree angles, and the parallelogram doesn't. So a parallelogram could be a rectangle if you added those 4 90-degree angles, but doesn't have to be sometimes. A rhombus has 2 pairs of parallel sides. Let's think. Here's a rhombus, and a rhombus has all congruent sides. Now, does that necessarily mean it has to have 2 pairs of parallel sides? Well, a rhombus is a type of parallelogram. You can look at the tree diagram if you need to remember this. And a parallelogram has 2 pairs of parallel sides. So a rhombus is actually always a parallelogram and always has to have those 2 pairs of parallel sides as being part of a parallelogram. It's an always. E, a trapezoid has 2 pairs of parallel sides. When you think of a trapezoid, by definition has 1 pair of parallel sides, and so it could never have 2 pairs of parallel sides. That would go against the definition. So, looking at these, remember, this first one, if something can't be something else, that's a never, right? If it could be, but doesn't have to be, it's a sometimes. And if it always has to be something, that's an always. Let's keep going with F. A rhombus has 4 right angles. So again, here's my rhombus. It's all congruent sides. Could it have 4 right angles? Well, I guess it could. I guess I could start with the 4 congruent sides and have 4 right angles. Then it'd be a square. But does it have to be a square? No, it doesn't have to be a square. Sometimes. Again, you'll notice that rhombus is above a square in the tree diagram that you can refer to, and so again, this would be a sometimes by the tree diagram. G, the opposite sides in a parallelogram are congruent. Well, so parallelogram, all right. Well, we learned that the opposite sides in a parallelogram are always congruent. That's just something we learned that always happens with parallelograms. Could they have opposite congruent sides? Yes, and in fact, it has to be. We learned that. Parallelograms always have congruent opposite sides. The opposite angles in a kite are congruent. Let's think about this for a second. Here's a kite. Here's a kite. Could the opposite angles be congruent? Well, if you're looking at this angle right here and this angle right here, those are congruent. That's true. But are every pair of opposite angles congruent? Well, let's think. This angle here are not congruent. So while some opposite angles in a kite are congruent, not all of them are. This will be a sometimes. And lastly, a trapezoid has base angles that are congruent. Let's think. Here's a trapezoid. Do these 2 angles have to be congruent? Well, they don't have to be, but they could be if you had an isosceles trapezoid, right? If you had an isosceles trapezoid right here, then the base angles would be congruent. So again, this will be a sometimes. Let's finish out with some quick sketches. 20. Sketch a rhombus that is also a rectangle, or explain why you cannot. So let's start by drawing a rhombus, just to get the idea here. Where a rhombus is a parallelogram with all congruent sides, and we need to make it so it's also a rectangle. A rectangle has those four 90-degree angles. Can we draw a quadrilateral that is both all congruent sides and 90-degree angles? In fact, we can. That shape will be a square. So all you need to do is draw a square. It's got the attributes of both a rectangle and a rhombus. And there it is. Sketch a trapezoid that is not isosceles, or explain why you cannot, for 21. So an isosceles trapezoid looks something like this, right? It's got those congruent sides and the parallel sides. So all you've got to do is just draw a trapezoid that doesn't have these congruent sides, right? So maybe I'll make it look like this. This is a good example because you can definitely tell that these sides are not congruent and that these angles are not congruent either. This looks like a right angle and this is not. So even though the top and bottom are parallel, that makes it a trapezoid but not isosceles because the non-parallel sides are not congruent. Sketch a kite with four obtuse angles for 22. Explain why you cannot. Think for a second. Obtuse means greater than 90. Right? Greater than 90 degrees. And if we had four angles that were all greater than 90 degrees, then all the angles would add up to more than 360. So I don't think you can actually have any quadrilateral that has four obtuse angles. Here's a little bit of a clear explanation. Four obtuse angles would sum to more than 360, just like we said. And any quadrilateral, including kite, cannot have more than 360 degrees in its interior angles. In fact, it's supposed to have exactly 360 degrees. But if you take four obtuse angles, four angles that are greater than 90, they're going to add up to more than 360, and that's not going to work. So here's a picture of what that could look like. Here's your 1, 2, 3, 4 obtuse angles. And as you can see, the quadrilateral does not close with those obtuse angles, so this is impossible. If you've watched all the way to the end, congratulations, you've gotten to the end of this worksheet. Hopefully some of the examples have shown you how to do these different kinds of problems. Make sure you go back and watch just the problems that you need to watch again. Don't feel like you need to sit through this entire video another time. And make sure you ask questions to me, to your friends, to other teachers if you're having problems.